Check one, check, and we are live. Things are a little bit chaotic here today. Uh, wow. So, first off, I don't see any viewers here, so I'm not going to stress out about it too bad, but I'm just going to start off with I am exhausted. Um, Usually don't have a problem with not being able to sleep and stuff, but man, ever since I got laid off, I hit these stages where I just don't sleep for days on end. And we're into another one of those cycles. I got to turn that fan off. Um, Out here in the home lab, everything is about managing heat right now, and I've got a long-term plan for ducting out all the heat coming from the servers back behind me. Got a whole plan for that, and then we're gonna put a big mini split in. You're probably tired of hearing me talk about this, but when I do the stream, I've got like the Toshiba Mini AC heater over here in the corner, which is really loud, and it does the lion's share of our thermal management. And then I've got a ridge vent kind of fan up above me that's really loud too, that I keep constantly rolling just to keep hot air out pushed out of the ceiling. But anyways, have to get all that shut down. But here we go. Last episode, our last stream, we had stood up our ProxMox cluster environment. We had a lot of problems. And I think I've already told everybody this. I am not a ProxMox expert. I'm working on it. Plan on taking their class here soon, I hope. Got to figure out a couple things with that. Again, trying to prioritize money and opportunity right now to the best of my ability. But little by little, I think the best way to learn things, which is why we have home labs, why we do content like this, why we do demo environments for customers around new products or even upgrades in products, like I've done a lot in my career, is to learn. Cisco had a caching service. I don't even remember what it was called back in the day. It was a caching server box. It's horrible. There was a lot better products that had been out there at the time, but it was a WAN caching product, and I literally spent close to 20 hours in the lab and then went to the client to demo that product um, without any sleep or without anything. Like it was a grind, but we had a small window from the time we got the demo gear to the demo with the client, and it just failed and failed and failed over and over and over again. But when we were done, we were able to do an active demo with the client, and we actually had a demo case that we understood very, very well moving forward with the company I was with at the time, which was Cisco VAR, which was then acquired and a bunch of other stuff. But anyways, neither here nor there. We do this to learn. So some of my stuff's gonna be good, bad, and ugly. Anybody who tells you they go to work every day and they hit all the right buttons the first time and they're flawless and all their solutions are bang on, that's just garbage. We all learn, we all make mistakes, and that's part of the excitement of it. I got into tech to solve problems. That started off with desktops, and then it went on to servers, and then it went on to networking. I kind of came the opposite way that a lot of people come into this. I started off with desktop support, but I like to solve problems. I like to figure things out. So that's what we're doing here today. So with that said, let's talk about a couple of the problems we had last time. So when we were in here last time, I went into storage and I added PBS. And PBS is our ProxMox Backup Server. And we'll go ahead. Let's launch two more things here. I'm going to launch our ProxMox Backup Server, and I'm going to launch PBE 1 and 2 to make sure they're both okay in here. So PBE 1, PBE 2. Let's go to root passwords, get things organized here. ProxMox Backup Server, login. Allegedly, that would be bad if this didn't log in for some reason. Oh, my realm's wrong, I think. Realm needs to be set for PAM authentication. There we go. Cool. We'll get more into that later, but we had talked about it a little bit last time that you've got two different types of authentication in ProxMox. You've got PAM. You can actually have more, and we're really going to get to that later. But PAM is just the local Linux file system administration, login, and then there's the ProxMox login or the ProxMox Backup Server domain logins, and those allow you to create and manage accounts within ProxMox. And then later we're going to add, probably through Authentic, an actual identity provider login. Authentic is pretty cool product from what I've seen so far. I've had a couple issues getting it going. Like the product itself is up and running, but getting authentication to pass through correctly hasn't been right on a couple of my services, so we'll do that later. Um, Again, just so all of you remember what we're kind of doing here, my point of doing these streams is to not only like show Proxmox, but to show building lightweight enterprise services. So things like doing the load balancer with my Pi holes, so my DNS, in order so I have load balanced DNS. If one server goes down, we're going to do more services like that. Um, Also, I want to do an actual identity provider. I've also talked about my service catalog. Like, this is all this most of the services I'm running, and I want to have like a visual service catalog so we can have things like URLs that go right to the links, so we can interact correctly. I just think this is really the right way to do things, whether it's enterprise or not. If you're in enterprise into an Okta, you've got service catalogs. I like the idea. I think it would be super helpful in Teams. And it would take away a lot of like the note taking and mental like strain of like, oh, where's this, where does that. I just think this is the right way, and we're going to expand our service catalog overall in the future, but right now that's what we got. All right, so let's get back to this. Sorry, my nose is itchy. I don't know why. So let's get back into here. We said storage and we said PBS. When we were in here last time, I could not get backups to work. I couldn't get restores to work. I could map, but that's all I could do. So the long and short with that is I was on the wrong NIC. If we go, so backups up, it's working. You can see I even recovered VLAN 10 test from the old cluster. I backed it up and then I pushed it across, recovered it from a backup, and we'll show recoveries a little bit. But more importantly, if you go into network, you'll see these. So backup rep, Ceph, CoreOSync, and then this Linux bridge is our primary management. And so if we go in here and we do MGMT and application public app. And we'll copy that and take that across here in a second. I just want to make sure we have consistency across here. We'll do this on node 2 as well. Cool. But the whole point of this is that when I originally did backup replication and migration the other day, I had the wrong NIC. All of my NICs are already predefined in my network. So I've already got the Unify aggregation switch set up as all of its VLANs on the right ports. I've got the Cisco 3560, that's my gig switch, already set up on all of its ports. And these ports were 10 gig, and I was not getting these right. So that's why, and I think it was actually on PBE2 that we weren't getting them right. And I think I had a reverse backup replication and migration with Ceph Storage on this box. And I just need to get my diagramming built out better. And I think most of this stuff is actually defined really well in NetBox, but I'm not using NetBox for a whole lot right now. We'll get to that as we go on because I want to get into more automation and show what we can and can't do with it and all that stuff. But all that said, if you remember the last episode, we could not get ProxMox Backup Server, I think on PBE2, the new host in the cluster, to actually show up correctly. It was just grayed out, question mark, all that stuff. It's fixed. It was just a matter of getting the right network interface tied to the right VLAN. I could have just switched the VLAN on the infrastructure, but I just checked NICs and then re-IP'd and stuff after you were all off screen. In cluster setup 2, we also had migration network issues, and that all went back again to backup replication migration network. That's all about being on the right network to communicate to the right hosts in the right way. The other problem we had is once we had stuff up here, I couldn't live migrate between things. And if we go look here and we go right click and we do a migrate, this VLAN 10 test is off right now, but I'm just going to do a migrate on it. And it's going to run through this, and it should be pretty quick. Not a whole lot's changed, but we're just going to let that run. But the whole thing with this was that if you look at the storage nodes here, where you have local PVEC1, PBS1, PVEC1, PVE1 pool 1, and then where you have like local network PVE1 and PVE2. If you, what Proxmox expects from you is that you're going to transition a you're going to migrate a VM from same storage to same storage. The host name doesn't matter, but the local does. So what I had to do is I played around with this, and it became pretty obvious to me really quick that, oh, the problem here isn't that the storage doesn't exist or the storage is the wrong configuration. It's that the naming's wrong. And I got that through just digging around the logs and looking at that stuff. And then when, out of curiosity, I went and looked on the forums and in the man pages and stuff, I found out for sure that Proxmox does expect you that if you're going to have a VM, say, living in PVEC pool 1 on PVEC1, that needs to exist in the exact same name on PVEC2, and then it'll do a like-to-like migration between storage names. So in this case, yeah, and if you look right here, like we've already completed, we completed the migration. We started off on 2, now we're on 1. I just want to show you guys it's working. Like the whole point of this is to learn things and to figure out what works and what doesn't. So these names are important. In reading, it looks like there are some CLI commands where I can actually say, no, I want to start here and go here as far as storage on a cluster. And I think that's going to be important too. Because I wanted to recover all of my hosts to the to this PVE1 pool 1, and if we go look at that, that is actually a ZFS pool, and it's under this. It's right here. So we have a 1.79 terabyte pool of storage that we're using for local storage right now. I did that because I kind of want it up. I want the ability to recover the cluster if we have problems with Ceph. I'm not totally sold on Ceph yet, based on some things that some folks have told me, and also based on the fact that I spun up a nested lab in this environment because I didn't want to do all the Ceph installs and all the Ceph work without all of you here. I didn't want to miss steps and people be like, oh, what did he just do? So I did it in a nested lab, and quite honestly, Ceph standing up in a nested lab was dead simple. If it's that simple today, then I'm pretty excited about it. The problem being, one, deploying a VM onto that storage, or any storage, honestly, in the nested array took hours. Like the lightest weight Linux install I could get, like I think it was 500 meg, took hours. And I think that was more a function of the nested aspect of this than it was anything about Ceph. But hey, we'll figure that out as we go along. So, but anyways, we set up a ZFS pool. And that ZFS pool is acting as that PVEC1 pool 1 cluster, right, or storage node right now. And then if we go look, we have other disks that aren't currently assigned that we're going to use. So if you look here, we have quite a few other disks that aren't actually tied to volumes. So you can see the ZFS reserved ones, and then we have some that aren't as well. So SDF, SDG, and SDH. And then when we go over to PVEC2 and the disks, we had to set up this the way we did right now. I'm not super happy with it, but I think we're going to be able to use multiple disks on PVEC1, cluster unit 1, to set up Ceph, and then one node on PVEC2. And then at that point, what we're going to do is we're going to bring the third cluster node in, burn it down, bring it in, probably totally off stream because it takes a lot of time and we've already gone through all the steps. But then we'll have a 3-node cluster that will be configured across Ceph, and then we'll get to play with Ceph more and understand it. All right, so that gets us to that part of it. The other thing I wanted to show you, so let's go back into the data center side, look at storage. The other thing is we had this ISO image thing, and I've gone over this with all of you a couple times, that natively in 8.2, at some point previously apparently it did, but in 8.2 the ISO local share doesn't replicate across the cluster. In the past, I think they'd used rsync or something to make sure that the ISO share was available in every cluster node. You can't do that now. So what we have done is we set up um, TrueNAS, and then TrueNAS has an SMB share off of it, and then off that SMB share, we map that SMB share, Ceph's SMB share, to this host for ISO images only. And what that gets us is the ability to then go into every node. Is when you set the storage up, and when you set any storage, I should say, up in the data center, that then replicates for the host. So you see we have ISO, that's on host 1 and 2. We have local, that's in 1 and 2. We have PBS1, it's in 1 and 2. Same thing with the pools. And that natively happens like when you set up pools. That just automatically ends in the data center. So it enables things like the migration. And we should see that with Ceph. The Ceph pool should natively get installed into the data center tier. And you can really screw things up, like if you go delete them out of the data center tier and then they come off the rest of the hosts. All right. So then the next problem we were having is that when I went into this ISO section, we weren't seeing these. There's an interesting thing about how the ISO share works. The ISO share doesn't look at the root and go, oh, there's ISO there. Instead, ProxMox looks for /template/ISO. And what was really weird to me was PVEC1 was not seeing the ISOs. This was all blank. And when I would try to create a VM and I would go to ISO image, this was blank when I was on PVEC1. But when I would go down to PVEC2 and I do ISO, it would populate. And when I would do create VM with that host selected and I would choose the ISOs, it would populate. So all my ISOs were showing up right for one host, but not the other. And one of the things about that /template/ISO structure is that when you join a data center to it, it'll look at that and say that's fine. But then the individual hosts want to see that file structure as well. And PVEC1 kept recreating that file structure. So even though I had pointed it at /ISO or /template/ISO or /template, no matter what subdirectory I gave that, every time I would try to access this ISO volume and I'd be looking at the file structure on a Windows box with a share, it would come up and it would recreate the file structure inside the ISO folder or inside the template folder. And it would just keep nesting and nesting and nesting, and it never worked right. So what I did is I left everything here the way it was so it wouldn't recreate it. And then I went and copied all the ISO folders to the new one that was created. It was just simpler. But the long and short is I moved all my ISO files to the new file structure, deleted it at the data center, brought it back, and then both hosts were fine. I'm sure I'm missing something there, and I'll go dig on that later, but I want to move forward with this and not just sit here and troubleshoot on a minor issue like that. That probably won't even be an issue in a bigger cluster. So moving forward. So that catches me up on my post-it notes of what I screwed up last time. And again, last time was a matter of just goofiness with ISOs, not having directories named properly, and having the wrong network interfaces IP'd. The one final thing is we also had a double IP between the old cluster and the new cluster. We eliminated that. I don't think it was really causing problems, but we eliminated it anyways. It didn't seem to solve anything when we fixed it, although it should have. We should have seen a lot of inconsistency with two live IPs, but neither here nor there. Small environment, low hit rates, different MAC addresses. The IP and the MAC host weren't sharing the same MAC addresses. That would have caused a lot more havoc. But anyways, here we are. So tonight we're going to do Ceph. And Ceph's going to take a while, and we're already probably a few minutes in. I don't see my... Oh, we're already 23 minutes in, so I'm burning daylight here. All right, so we're going to go in, and we are going to go down into Ceph. And we're going to click Install Ceph. And by the way, I already have all my repositories set up. You saw me do that in the last stream. It's going to ask me to find those again. And I'm going to move really quick here because this takes a few minutes, and then we'll kind of slow it down after the core stuff's done. So Ceph, we're going to install Ceph. Right here, even though we have this set, in our cluster repositories, it asks us to do it again. So we're doing Reef. Reef is the current one. I haven't dug into the reasons why or why not, but we're sticking with Reef. It's the current release train. And we're going to do the no subscription repository, and we're going to start the Reef install. And then because it's going to screw things up here, I'm going to tell it yes. If I don't want to kill this, I want to let it run. We're going to go over to PVEC2 in its own window, same cluster, but different management window. And we're going to go in and do a Ceph install on this guy from here. So Ceph, install Ceph. We're going to do the exact same thing, no subscription, Reef 18.2, start the install. And I think we talked about this last time. These are just apt installs. These are apt-get install windows. So we're going to go stick around on this one for a minute. Just as an overview, I'm going to bring up the network config just so we all see what we're working with here. This is the 2 node that we're building out, and this is going to be what it looks like. We're going to have a dedicated management interface. We're going to have a dedicated CoreOSync interface, dedicated backup, replication, and migration. This is 10 gig. The others were 1 gig. And then we're going to have storage and Ceph. I left it at storage because I might do some other stuff like putting the ISO server over on storage later. That way it has a 10 gig path. Right now, that path is usually 1 gig, and you can definitely tell it in some of the spin ups. But this is the network we're working with. It's pretty straightforward. 4 total VLANs. We're not talking about the application public interfaces. We're not talking about the rest of the lab network. We'll glance at that real quick. This is the overall lab network. These are all the VLANs, all the gateways, all the different things, IPMI, production or application public. All that's in here. We don't care about that right now. That's for future stuff and just keeping the core network running. This is what we're doing tonight. This is the network we're working with tonight. So with that said, we're going to jump back over to here, continuing to upgrade all this. I think we're at this stage where we can hit next, because I think this locked up here the other night. Yep, we sure did. So if you have your networks labeled correctly and IP'd correctly ahead of this step, which we did, then you're just going to go to this drop down and you're going to choose your storage and Ceph network. We know it's our our 13 VLAN or VLAN 13, and we're keeping the 3rd octet all synced in there. So we're going to choose that one. That is actually, I am wrong here. I did this the other night and I caused some havoc. So the public network, I'm trying to remember what they mean by the public and then the cluster network. All right, so here's what we're going to do. Our public network is the network that people can talk on and all of that stuff. And we're going to choose storage and Ceph here. And then the cluster network, if I remember correctly, is where all of the synchronization and everything is happening. We're just going to choose storage and Ceph for both of them. This should probably be isolated in any other network. And if I had enough 10 gig interfaces and enough 10 gig switch ports, I would do it. So the public network, I'm pretty sure, is where the hosts are talking to it, where that file system is attached, and then it can pull up. The cluster network is where it is doing all the synchronization and making sure all the data is synced across. We might change this at some point, but yeah, but I'm just going to keep storage and Ceph there right now. I forgot totally about this. Caught me a little off guard. It's my bad. So with that said, we're going to have number of replicas is 3. Minimum's 2. We have 2. We'll have 3 here in a little bit. And when I did it in the nested lab the other night, we did 3 and everything was great. We might have some goofiness as we go through this, but we're just going to keep going here. So next, we're going to tell it to do that. And then it says install Ceph monitors, create OSDs, create pools. We're going to click finish. We're going to go back here. We're going to tell it next. We're going to do the same thing we did before, which is Ceph and Ceph, both 10 gig interfaces. Could not connect to the cluster despite configured monitors. All right, let's do this. So let's now go look at Ceph and let's look at configuration. Let's look at monitors. We have our monitors up. OSDs are actually your disks. This is where we'll assign individual OSDs to it. Ceph file system, I'm a little confused by at this point, but we'll get back to that. And then pools are where you take and you compile your OSDs into a storage layer pool that then synchronized across all the hosts, and then you can use that pool. This shouldn't have happened. So if we go back to configuration, minimal replicas, additional monitors are recommended. This should complete. This completed in the lab just fine the other day. Could not connect to Ceph cluster despite configured monitors. All right, let's do this. Let's kill this. Let's go back to PBEC1. Let's go to node 2. Let's go to Ceph. So if we look at Ceph here, it's not configured. It's a bit of a problem. Yeah, we're getting an error timeout. I don't know why. So let's go back up to PVEC1. Let's go up to data center. Go to Ceph at the data center layer. OSD count is 0. We expect that. We only see PVEC1 for monitors and managers right now. That's not what we want to see. That's not how this should have gone. But let's go back into here. Let's go into Ceph. We're seeing the same thing, standard monitor manager. We go into configuration. We're allowing there's our monitor. It's at 10 or 1312. OSD Ceph log. So if we go to log, and I'm gonna say, like, I haven't messed around with logs a lot, but with the storage problems I was having the other day, man, logs have come in. Like almost every function in ProxMox has live streaming logs. So that's huge in solving some of this problem. Let's go back to PVEC2. Let's go to Ceph. It's not seeing any monitors or managers. It's getting a timeout. That's the thing that's concerning me. It shouldn't be getting a timeout from Ceph right now. And this looks like it's kind of locked up. So Ceph, under Ceph, let's go to configuration. So CephX, our cluster network is 13. Public network is 13. Monitor host is 12, so it's got that. No IPv6, true, 2 and 3. This all looks right. So we're going to go back to the monitors. Interesting. So our monitor just popped in. So this could be something to do with Ceph still setting up on that other host. Let's check that. And then if we go and look at data center and Ceph, we've still getting errors, which is fine because our monitor and our manager is the same thing. I would highly recommend you go read through Ceph docs. I'm still doing that, but again, we're pushing kind of forward on the bounds of what we know and what we don't know here to learn on the fly. So if we go into Ceph, it's now not seeing monitors or managers, and it's getting timeouts again. This screams of a network issue. And if it's a network issue, then we'll just troubleshoot it live here, and we'll get as far as we can in an hour tonight. So I'm going to go back to Ceph. So let's do this. Let's pull up MOBA X term, and we'll bring that over here. And then if we go look, just to clarify, make sure I'm hitting everything right, we want to hit 192.168.1.12 for our management interface on here. So let's do that. So we're going to open this and we're going to do session SSH 192.168.1.12 for our management interface for cluster node 1. We're going to specify, and it's going to be root. And then I am going to go over to 1Pass, which I have in the other window today. I did something smarter. We're going to copy the root password. And we're going to go ahead and connect here. We're going to accept. Dumped password. Didn't like that for some reason. Paste that. Yep, there we go. All right, so we're into PVEC1. So the key thing about this is we know, so if we do an IP-A, or IPA, sorry, it's going to show us all of our networks here. And we know that 10.1.13 is the Ceph network we're looking at. And in this network, we know the only IPs we're dealing with right now are 1 for the gateway, 12 for this host, and 13 for the other host. So we're going to start by pinging. Not that we need to get out of the broadcast domain, but I'm just checking the network connectivity at this point. So 10.1.13.1, and we can't ping that gateway. Okay, so then if we ping 12, we're fine, and if we ping 13, we're not getting it. So here's what it tells me. We were troubleshooting on PVEC2 the other day, and PVEC2 had the wrong network interfaces. So we're going to do this now. We're going to go back into our term. We're going to open up a new terminal, and we're going to test both sides of this. And we're going to do SSH into root at 192.168.1.13, which is the management interface of that cluster node 2. Tell it yes. Should be the same password. We've got them all synced up right now. I did not like that. Let me go back over here and pull passwords again. Yeah, it didn't like that. Let's try this again. Yeah, so it doesn't like my password there. Let's do this. Let's kill this. I don't know why that's not working. Let's just do this instead. We can do this. We can go to shell. Like I said before, this gives us a root shell actually on the box as a console right out of ProxMox. It's quicker and dirtier. It's just not as flexible as having like a full terminal session open. So we're going to ping 10.1.13.1. We are definitely having network issues here. And I'm not quite sure why. This should have all been worked out. So if we try to ping 12, not going to work. We know that. Try to ping 13, it'll ping 13. So, all right, let's do this. Let's start at the top of the network. Let's go to Unify. We're going to VLAN 13. And we want to start by understanding what the configuration is on VLAN 13. So networks, we're going to go to VLAN 13, which is storage and Ceph. And if we look at it, it is 10.1.13.1. We know that, so the gateway should be there. VLANs 13, guest network, isolate, all of that stuff is set off. It's on the standard LAN interface for our router on a stick, effectively, for lack of a better term, for what we're doing here. This looks fine. So then, if we go to the ports, and then we look at these ports. So if we go, we have apply configurations right now in the network. So let's go look at that. I think that's just our naming, but maybe that's part of our problem too. You know what? I think that is part of our problem. I did the Ceph config earlier. Yeah, I'm dumb. Let's test this now. So we're going to go to shell. So I set the Ceph config up earlier and didn't apply it. So if we ping 10.1.10, or sorry, .13.1 now, still nothing. I don't like that. Let's do 12, should ping. Let's try 13. Yeah, we definitely have a network issue. This is not a host level issue here, folks. The good and the bad is you get to see all the different things that go into this. But you also get to see me screw up a lot. That doesn't bother me. I screw up a lot anyway. So we're definitely not getting to the gateway. And not getting to the gateway is the very first thing that bothers me. Every host should be able to get to its gateway. So 13, we're going to try 13. It can ping itself. We're going to try 12. Yeah, I can't do it. So within a layer 2 segment, everything should be able to ping its gateway. Everything should be able to ping everything else in it. So if everybody's in the right VLAN, it's just broadcast. It just screams who has this, and then it responds. It doesn't even have to get to the gateway. That's routing. As soon as it gets to the gateway, it has to go up and through the routing table and figure out where it has to go. But on a straight L2 network like we have here, everything should be fine. So let's do this. Let's go into PVEC1. Let's just check things. So we are on for Ceph and storage. We're on 10.1, 13, 12, 24. We're going to go to PVEC2, 10.1, 13, 13/24 Ceph and storage. That's great. The other thing, here's a quick thing. It's not networking. When you're actually in a data center and you're in the same host, as you switch between hosts, they'll keep the same config. So, or like same screen design. So it makes troubleshooting, like working through the cluster, helpful. So as an example, if we go to summary in PVEC1 and we go to PVEC2, you get the summary. That's just really cool. It's just a neat thing it does. It's little, but it just keeps you from having to jump around. It confused me the first couple times. And I'm like, oh, did I not move screens? But you absolutely are moving screens. All right, so let's go back to PVEC1. So cluster node 1 here. And we're going to bring up how many shells? I already got a bunch of shells up here. Let's kill these shells so we don't cause confusion. More confusion than we're already causing. As I mentioned earlier, I haven't slept much in the last 2 days, so I'm probably a little bit more confused than normal. We're going to go into shell here, and we're going to do IP-A, or sorry, IPA. And then what I'm looking for here is I want to find that 13 address for starters. So we're going to find 10.1, 13, 12. So right here. And then we're going to look at the Ethernet address on this. And the last 4 of that Ethernet are 68F2. So we know the Ceph network interface on this one. Its MAC address ends in 68F2. So we're going to go to the UniFi network here, and we're in the aggregation switch. So we are going to then look for the connection to 68F2, which is right here, and that is on port 4. So then what that tells me is I can look at the network it's in, and I can already tell you we have a problem here. So the network is the wrong network, and we're going to start solving problems right here. So what we're going to do is we're going to go in and we're going to change that one to storage and Ceph. We're going to hit apply. So now if we go back over to PVEC1 and we look at this, I should be able to ping the gateway now. Maybe. Oh, there we go. Took a second. So we must have had a blip there. So we're going to ping 10.1.13.1. Boom. There we go. That was a VLAN issue. I'm betting it's the issue on the other one. And then if we ping 13, we're still not going to see it because 13's not right. So when I flipped the networks around to get migration and storage and stuff right the other night, I didn't get this right. So we're going to leave that host. We're going to go into PVEC2 and we're going to open it shell. And we're going to do the same thing we just did again. We're going to just do some data validation. We're going to do IPA, and then we're going to look for the host that has the 13 address on it. And we're right here. Nope, that's not it. We're looking for the 10. So we're looking for 10.1.13.13 is what we should be looking for right here. 10.1.13.13. And its MAC address ends in 3D9C. So we're going to go back to Unify, and we're going to look at the last four and look for 3D9C. The problem we have here is 3D9C is not showing up as an actual interface on here, which is concerning. Should be. I don't know why it's not. So we're going to go manually trace that out is what we're going to do. So again, let's jump back into here. Let's just validate all this. We're looking at 10.1.13.13, which is our Ceph network. And the last four in its MAC address should be 3D9C. We're going to go back in here one more time. We're going to go into networks. Sorry. We're going to go into ports. And we're looking for 3D. We have some 3Ds, but we don't have a 9C. We know this is our uplink, and we know that this is one of our interfaces. If I had to guess, I'm guessing it's port 2, but I don't want to guess. So I am going to give this an I'll be right back. I'm going to keep you guys on mic, dump my headphone, and go physically trace out that interface right now to PVEC2. All right, so we're back. I think I've solved the problem. So again, we're in a home lab here. And when I bought my aggregation switch, it was the best one I could get at the time for the price. Again, I'm trying to keep costs down on it and all that stuff. But the problem with that is it's only 8 ports. And I have more than 8 ports of 10 gig that, I have exactly 8 ports of 10 gig that I need, but I also needed to uplink from this device into the network so it can talk to Unify and everything else, which means I had to sacrifice one of my 10 gig ports for GLCT electronic to go in and then upload it or uplink it to gig. I'm looking at getting a Cisco Nexus 3000. And they're actually about the same price as this guy, which probably would have been the smart move for me to do, and then to do Cat 6 10 gig connection and just do a Cat 6 one of those boxes. The problem is the one, I've already bought this. 2, the Cat 6 version, so the RJ45 connections box is quite a bit cheaper than the optic version by a couple $100 even on eBay. And I would really like to get that box. We just haven't done it yet. So, all right. So let's look at this again. And I'm going to refresh this. And then, all right, now we see it. So right there is 3D9C now. So yeah, this is definitely a network problem. We're going to go set this interface to storage and Ceph. The way I got around this just now was when I decided to set this up, my cluster host, one of my cluster hosts, I have planned to only be a backup one. My oldest of all my boxes and my loudest of all my boxes, I'm going to make a pure backup, bring it into the cluster, set everything up, and then bring it down. Instead of hooking in my 10 gig to my number 2 node, I had hooked it into my number 1 node, my 2 old nodes. I just pulled it, moved it, because it doesn't use this interface at all right now. It will when we set things up, but for now we're good. So we've just gone through all that troubleshoot. We burned a lot of time, but network, VLAN, physical layer, all that's just as important as all the other config we're doing. If you don't have good roads, if you don't have good mapping, you don't have all that, none of that's going to work. And this is just going to continue for me to figure out my network mapping better, get a larger switch in so I'm not having to juggle ports to do things, and move on and do all that. All right, so that said, we should be good now. So if I go to PVE1 and I go to Ceph, we're good except for OSD counts. When I go to PVE2 and Ceph, we're good. Managers are up. All right, pure networking issue solved. We're back and in good graces. So now we're going to go to PVE1. And we're going to go to our monitors, and our manager automatically got set up. Monitors and managers are key to Ceph. That's how you're accessing the Ceph cluster. It's how you're monitoring for changes in the Ceph cluster. Again, I recommend highly read up on Ceph. This isn't me trying to teach you Ceph. This is me trying to teach you how to set up Ceph and learn myself. All right, so then we're going to go to OSDs. To repeat what I said earlier, OSDs are how you map a disk into Ceph. You don't map a disk into a pool in Ceph and then take the pool and put it in Ceph. You do it kind of the reverse, and you create these OSDs. So the very first thing we're going to do is we're going to go to the disk for the OSD, and we're going to choose the first one open. And I left 3 disks open on this box. And we're going to leave everything just plain Jane here. We're not going to screw with DB disks, encryption, any of that. This is quick and dirty. We'll play with all that stuff in the future as we want to have encrypted data and all that other stuff. But right now, I just want to get this running, test it, do some validation. And like I had mentioned, we're going to be right at the kind of bare minimums to get a Ceph cluster up and running today until we have a 3rd node, but we're going to keep going. So then we're going to, okay, and did a quick little refresh there, and it shows that first OSD. We're going to create 2 more OSDs by mapping the other 2 disks that we left spare in here. So that leaves us with SDG. We're going to create. And then we're going to do the same thing for the very last disk that we left. We intentionally left 3 of our disks available to do Ceph. I also intentionally left enough disks of this master host to just do ZFS as well. And I did that because if the Ceph stuff doesn't work well enough because of my network or my disks or whatever, then what I want to do is I want to rotate back to ZFS because I know ZFS is bulletproof in these clusters. And it's probably not the right way to do enterprise, and it's sure not the way to do hyperconverged, but it's bulletproof as far as running a home lab. So I wanted the ability to roll back to that. All right, so we have our OSDs here. There should be 3 of them. Yep, the OSDs are up. They're in the cluster. It shows their total space, so a little over 1.5 terabyte in space there. We're then going to go into PBE2. I was only able to leave 1 disk free in here for now. And again, this is the nature of just running a lab. These hosts only have 3 nodes on them to begin with. I had to use one of those nodes as a boot volume. I had to use one of those nodes as a single disk ZFS. And now I'm using the other one as an OSD inside of Ceph. And these are terabyte drives or 2 terabyte drives. I forget. I think terabytes. So that should add a pretty good node into here and should be able to do most of the synchronization and stuff across those. So let's finish getting all this up. Shouldn't take too long here. The other thing I'm going to note is that we should, there we go. And then there's PVE C2 OSD 3, and it's a terabyte. So there you go. There's probably a lot of best practice stuff that goes into this stuff. And well, there is a lot of best practice. There shouldn't be, should be, there is. When you look at this, things like Ceph clusters, they say should be pretty much the same hardware. So the same cache drives, the same, primary storage drives, same all that. We don't have that luxury. If I was at a big environment in creating a ProxMox cluster from scratch, I would have probably high capacity storage nodes, high compute nodes, and they would all be part of the clusters. We've done that with systems I've worked on in the past. We've done it with Kubernetes clusters. We've done it with some other clusters that I've worked with in the past, and I know that you were able to do the same thing with Nutanix at one point. Like originally Nutanix, when I first bought it, was like every node has to be the same. and then they opened up more and more to the point you could even get like higher capacity storage nodes, and then you could get higher capacity compute nodes and mix them in with the cluster. So it's got to be the same concept here. And we're definitely starting off mixed. We're starting off with different RAM capacities, different storage capacities, different storage types, and we'll just kind of see how it goes. So we're going to go back up to PVEC1. We're going to go to Ceph here, and now we're going to look at pools. And with pools, what you're doing, if we create a pool, pool is what is going to give us the actual storage that is available to our actual um, host. That this is going to be what we present forward, is my understanding. So if I name this, we're going to call this cpool. I'm going to call it cpool 1. We'll just call it cpool 1. We're going to tell it how big we want this to be, the amount of data eventually stored in this pool. Minimum size, number of PGs, replication rule, and crush rule. We're going to leave all this kind of the right size here. This is all our replication size. So we're going to call it target size, and we're going to call it 1024 gigabytes. So that gives us a terabyte. And then if we look, we have cpool right here. And then it shows us all our VM disks that are living on cpool. Tells us our summary of cpool, which it's loading. It tells us 0 of 886 gigs are available. VM disk, volumes, all that stuff. So then we go up to data center, and we look at Ceph. Ceph is healthy. We have one subtrees that have an overcommitted pool. And that's kind of what we have right now. So let's try something. I want to see that Ceph's working, because this is my first time I've actually been able to do anything production-wise with Ceph. Ceph should be up at this point. We know it's not optimal. My drive size should have been like 500 probably, because it's not going to be able to map the entire drive. Like we have degraded redundancy here when you look at it. So PG2 is stuck undersized. All these are stuck undersized. So let's try something here. I'm going to go destroy that pool. We're going to make it 500 gig and see if we eliminate some of those problems. So if we go to PVEC1 and then we go to pools, and then we're going to destroy that pool. And just like anything in ProxMox, you have to give it the identifier to remove it correctly. Okay, so then we're going to create a pool, and we're going to name it cpool1 again, and we're going to do 500 gigabytes, which is the max size of one of our OSDs or one of our drives. Minimum pool size is 3, maximum's 2, or sorry, size is 3, minimum size is 2, all that stuff. Number of PGs. Like, I'm not sure what the PG thing is. Like, again, this is me not fully understanding it, but let's just leave it at that. So let's do a create. I also feel like this is when you're doing things like a lot of times in production or in home lab, you're like just doing. You're just trying to race through and get it done and get it to production. Then you run into problems, or then you run into questions. And one of those questions is, what specifically is a PG? So I've got a note, what is a PG in Ceph? And it's currently set at 128 question mark. So I'm going to go look that up offline here, because the research on this stuff is the stuff that really takes a lot of time and makes it not interesting to you guys if I'm just sitting reading docs. But fumbling through this is probably more interesting. So let's go look again. Let's go look at our Ceph state. Okay. So now we have no warnings or errors on Ceph. It is active plus undersized. So I'm guessing this is about the number of drives. And if you look here, it's telling us that we're using 107 meg of 2.5 terabytes over on this. So yeah, let's go ahead and see what we end up with here. So if we go and we look at cpool and we look at a summary of cpool, cpool is actually telling us it's got 900 gig in it. So I have to understand better, and it's telling you 886 here again. I have to understand better when we created that pool. So if we go back to here and we look at this pool, I told it 500 was the target size. The amount of data eventually stored in this pool used for auto scaling. So yeah, minimum number of PGs, let's say 4. You know what? I'm just going to cheat for a second here. I'm going to open up another window. I'm even going to show you guys. What is a PG in Ceph? Let's just figure it out together. PG is a subset of a pool that serves to contain a collection of objects. Ceph shards a pool into a series of PGs. Then the crush algorithm takes the cluster map and the status of the cluster into account and distributes the PGs evenly to pseudo-random OSDs. Okay, so the PGs are all the little clusters that then get puked out over to the OSDs and shared. Interesting. Okay, I'm not sure how that applies to anything I'm doing here. I think I'm just going to cancel that. I'm not going to okay and apply that. If we go back to minimum number of PGs, it says 0. That doesn't seem right either. But anyways, I've got some definite Ceph tuning, but I think Ceph's up. So what we've said is we've created a Ceph pool. That Ceph pool, the target size and ratio, all this stuff. This is so the amount of data eventually stored in the pool, and it's used for auto scaling. Okay, let's just leave it at that for now. Maybe that's our max auto scaling. Right now, let's see if we made this work. So we're going to go on PVEC1. And if you look, I told you it was important that the names were identical. So when it created cpool1, it created cpool1 on both PVEC1 and PVEC2. If those didn't match, then we couldn't do things like migrate around them. The other thing is that it did, if we go to the data center and we go to storage, you'll look at added cpool right here. And it by default told it disk imaging container. Now we could go in here and look at those specifically, but that's what it defined those natively for the pool. All right, so let's do this. So now we're going to go into our PBS backup. And here's where I'm going to jump over into the old cluster. And I want to point out an interesting thing right here. Last time you guys saw this cluster, this was the original cluster of 2 units. It had PVE1 and then PVE2 was blocked out. I needed to get it back effectively out of a cluster and into a quorum of 1. So the cluster still exists. And if we go look at the cluster notes, it tells us there's only 1 here. But if I wanted to add other things back into this cluster, I absolutely could. And as we've talked before, it might have just been smart for me to add the newer node into this cluster, bring it up, tear some ZFS volumes down, and then recreate the cluster on the fly. But I wanted to show the backup and recovery process. I wanted to show moving from a cluster to another cluster. That was my first goal, because a lot of you are going to be looking at this content and going, how do I get from VMware to this? And this is one of your paths to some extent. But I wanted to show an equivalent of moving from one cluster to the other. But on this one, what I wanted, I lost the ability to make any changes, turn a VM up, turn a VM down, because there was a cluster in place that had a minimum of 2 quorum nodes required. So what I did is there's a command, the commands for the cluster for ProxMox are PVECM. So what I did is I went in, and I'm not going to do it again, but I just went into my shell and I did, like, so if we do a PVECM status, it'll show us the status of the cluster. And one of the things you're going to see here is expected votes and expected quorum of 1. So what I did is I did a PVECM expect 1. And then I did a PVECM del node PVE2, which deletes the node out of the cluster. So first off, I told it to expect a quorum of 1 so I could get back control of my cluster. Then I said get rid of the old node that was dead. So whether that hardware died, whether we repurposed that hardware, whether we were having issues and we just needed to bring it down and bring it back in, whatever, we got rid of that node. So what that leaves us, it leaves us with this quorum state of only expecting 1, and it leaves me with a node that I can bring things up and down on. So we've used this Kali 1 node quite a bit to kind of show off. I've also done this VLAN test node, but I'm going to do the Kali because if we go back over to the cluster here, so you'll see that Kali's off. I don't want to migrate something over that's already up or that we're counting on right now. But if you look, I already recovered that VLAN 10 test earlier, and I'll go ahead and start it as we're talking here, just so you can see that it's working. It's actually the VM. This is a straight recovery from going into ProxMox Backup, looking at the backups that exist, finding the VLAN 10 test, and doing a restore. This is exactly what we're going to do on the Kali box here in a minute. But if we go into this box, we're pulling up its console. You're going to see it's booting. It's doing the whole VLAN 10 test Ubuntu box that we built before. This should come up super quick and clean. I showed you a migration already on it. So we're going to bring this up. Going to log in. We're going to ping an outside host, so 1.1.1.1. Boom. This is the VLAN 10 test. It's up. I can do an IPA on it. I can show you it's on VLAN 10, so 10.1.10.25 is the IP on it. We know that's VLAN 10 based on the kind of structure that we've set up through all this. Or even if you don't believe me, if we want to go back and look at this, so VLAN 10 is not on here. We don't have it on here right now. That's fine. It's moot to what we're doing. If we go back over to here and we look at VLAN 10, it's the production VLAN for new production endpoint host. So it's going to be 10.1.10, and that's all that we were testing when we built that host. But it's up, it works. We'll leave it on. We're in a functioning cluster now with functioning cluster storage. I'm even going to do one more thing just out of curiosity. We're going to do a migrate, and we're going to tell it PBE to 2. Now, this is interesting because I couldn't do this the other day, and I wasn't sure if I was going to be able to do this. So right now I'm sitting on PBE 1 pool 1, and it's telling me that I can migrate that to pool 1, which is the new Ceph pool. So I'm going to do it. It's only a 32 gig VM. It's not huge. Those are 10 gig networks. I'm going to see what happens because this is what my hope was. My hope was that I could have recovered everything already offline before I built Ceph out for all of you. I actually mentioned this even at the beginning of the stream here, and then migrate them all into another pool. So let's go ahead and do that. I'm going to hit migrate. We'll see if it actually goes. Hopefully it does. Because then what this does is this means that once I'm in a node, if I have, say, a backup ZFS pool and a primary Ceph, if we were having problems on Ceph, then I could pull everything into the ZFS. It would also mean things like I could do transitions from one Ceph pool to another. I could do migrations from potentially one ZFS pool to another. And if we look, it seems to just be going. So I'm not going to complain about that. We're going to kill that for now. That's going to be really cool if it works. But now we're going to do the backup. So so PVEC1 is by far my most powerful host right now. If we look at this guy and we look at a summary of him, like he's got 56 cores, or he's got 56 CPUs. He's got a ton of RAM. He's got 251 gig of RAM. Hard drive space is not, it's got a bigger chunk of hard drive space than anything other than my backup server right now, but that's not really the point. But this is a pretty beefy box, and it's going to be our best box for doing this stuff. So we're going to go on PVEC1. We're going to handle all of our initial backups here, and then we'll migrate them around the cluster. I'll probably do some backups on PVEC2 just to show that I can and there's no network issues. But anyways, here we go. So we're going to go to PBS, which is our ProxMox Backup Server. This is this box right here. and you can see all the different stuff on him. You can see he's got 21.19 terabyte. He's only used 512. We can see the longest tasks and what they've been. A bunch of configuration stuff here. We're going to do more with him later. We're going to do things like add remotes up in the public cloud, but neither here nor there. We've already joined him because of the native interlock between ProxMox virtual environment and ProxMox Backup Server. All you have to do is click on this storage host, which is PBS1, which is that box we just pointed out. Go to Backups, and it shows us all. We want to recover Kali 1, and I'm going to find the most recent Kali 1, which these are sorted by date. So it should just pop up here as soon as I find a Kali 1. So we're going to click Kali 1. I'm going to not right click. Right clicks don't do a whole lot in the ProxMox stuff just because HTML and browsers and all that. But anyways, I'm going to click restore. We're going to tell it storage on this host, and I want it to restore to cpool 1. The other thing is we can set a new VM identifier name in here. I don't want to do that. So if you look right here, the original VM identifier on the previous cluster was 108. We're going to stick to 108. I just want to kind of bring things over one for one what they were before. We can choose start after restore. We can choose live restore. We can put bandwidth limits in. We can do a bunch of different stuff. We can generate all brand new unique MAC addresses. I don't want to do any of that right now. I don't want to cause chaos and anything else. This is a down host. If I was doing some sort of migration of a live host, which we might try later, I'd generate a new MAC address so we didn't have MAC conflict, and go from there. Live restore is interesting. What they don't tell you a whole lot about here is a live restore, if you click that, within a very short window of time, you'll be able to go into the console and start doing things. Interact with that host because it kind of streams over the base level of stuff and then it streams more data in over time. What they kind of were trying to tell us there, though, is if data is getting written to that, it could be overwritten. You could lose data if it fails, lots of stuff. This would be more interesting to me if ProxMox Backup Server could look at the original source and I could have something like my Kemp load balancer. If I could say I want to do a live restore on Kemp, and it would go, okay, Kemp load balancer over here, we're restoring. That's assuming both sides are live, right? And then it would get to a point where it was live enough on the new host that it would then shut down the Kemp load balancer on the old host. And at that point, I could have a live environment. I could do a live migrate between clusters. That's not what it is right now. Who knows what they're planning for the future, but that would be cool to me. Otherwise, the live upgrade doesn't seem to have a huge benefit to me unless you had some really critical static stuff that had gone down and you were trying to recover, or you had blown up a host, say like a WordPress site or a documentation site, and you're trying to bring it back, and your goal was to get up as quick as humanly possible, and it didn't have a lot of reliance outside of its own server base, and you were just trying to recover that one. I see benefit there, and maybe we'll play with that some, spin up like a WordPress box, like an all-in contained LAMP stack in a box, and then try that later and see what it looks like. But for now, we're not going to do any of that. We're just going to click restore. The restores are actually pretty quick on here. This Kali box isn't huge. I forget exactly how big it is. We can go look. It's 107 gig. That's not tiny, but it's also not massive. So it's downline verifying the index on it right now. If you can see up here, it's locked. This is the typical thing that the ProxMox backup does. If you get failed backups, we had talked about an unlock command where you can actually do in and do a QM unlock on the node. It's part of my notes that I have up at my data center tier because I've had to do it enough, especially with not having like all 100 gig and, having to share networks and stuff. Occasionally things just don't back up right. So we're saying progress here is at 1%, 2%. I'm going to close that for a minute. we're going to jump back over here and look at the migrate job that's going on. And it just finished that migrate job, it looks like, actually. Um, okay, so it mirrored the job first, so that's kind of cool. So because it's moving between storage, it actually had to do the full 32 gig transfer. Not shocked about that. In ZFS, when we have replication, it's replicating that, so it usually is pretty up to date. And the only thing you see it move is the 4 gig memory footprint. But in this case, first off, there's no ZFS replication going on right now. We don't plan on using it. And we are moving from ZSF to Ceph, so it had to do a full migration. It had to do a full ship over of that. And if we look over here, it's up and live now after it's done that memory footprint and stuff. So it did all the data transfer, then it snapshotted the memory. It did the 4 gig memory transplant across. So then if we go in here and look, we're back into that VLAN 10 host. Look, my console's still up with me logged in. So we're good to go. And if we do ping 1.1.1. Let's try this again, 1.1.1.1, and we're pinging. So that host never went down again. If we would have watched it live, especially in that memory transfer, host to host, we probably lost 1 or 2 pings. And it definitely took longer because it had to do a full 32 gig transfer. But that's cool. We just proved out that we can go from ZFS pools to Ceph pools in migration. That gives us a ton more flexibility, and that actually makes me really excited. All right, so let's go back here and look at our restore. We're at 64% already. This thing's humming along pretty well. It'll be done here in a minute. So what we're going to do from here is we're going to let this get up. We're going to check kind of status on Ceph as quickly as we can. And then what I'm going to do is I'm going to do the migration Ceph to Ceph. And I want to see what the migration looks like Ceph to Ceph, if Ceph's up and running, what the performance looks like, just at a very high level. Like we're not getting deep into the gooiness of Ceph at all today. I just want to show it works. And again, we've already showed that it works as a storage medium because we now have our VLAN 10 test Livy on it. So if we go look at PBE 1 pool 1 and we look at VM disk, there's none on it. But if we go to C pool 1, which is our Ceph pool, then we see, this is cool, we see both VM 122, which is our VLAN 10 test, and we see 108. And we're on PVEC2. What this tells me, so if we go down here, one, there's nothing there, but there could be a difference between what's on one host and the other. So like if we go, yeah, totally, this is the perfect way to show this. So this is the ZFS volume on PVE1C. And if we look, Kali is up. Kali has finished its transition. Its restore is done. Sorry, I'm jumping all over the place. But look, we recovered. And does it tell us how long it took? It took 206 seconds at an average of 496 megabytes per second over that 10 gig interface. So cool. Good recovery time. What I was going to say here, though, is interesting, though, is we're looking at the ZFS pool on host 1. This 3301 is the lab that I built out for Ceph as the nested environment. And those images are all still there. Those need to go away. They should have been cleaned up when I nuked them. For some reason, they weren't. But what you don't then see is that on PVEC2. If I had replication set up, you would see those replicate back and forth and try to stay in sync, but I didn't have replication set up. You all watch me do Ceph setup from end to end. So if we go and look at C pool 1 has 108 and 122. We go to C pool 1 on PVE2, it has disk 1 and 2. Replication's native. That's the whole point of Ceph, which is that you take local storage, you bring it into a clustered managed environment. You don't have to set up replication. You don't have to do all this stuff. You have a shared file system across all of these hosts. That's cool. That's exactly what we wanted to see. So now we're going to click on Kali. We're going to start Kali. You guys have seen me use the Kali box as kind of our validation box over and over. If we go to hardware on it and we look at the network, you're going to see that there's no VLAN, so it should be natively in 192.168.1.1. So Kali's coming up here. Let's bring up the console for Kali. Boom, right up, quick. Maybe quick. Maybe just freaked out. Not really sure what's going on. There we go. All right. So, come on. So let's try root and then it's going to be so much better when I have a common authentication source set up for all this stuff. And then I can quit guessing whether it's root, admin, J. O'Brien, whatever else. We'll just have a common centralized management. And that's what we're going to do with Authentic. All right, we are up. So we're going to do an IPA on this guy. You're going to see 192.168.1.25. So we're going to ping. We're just going to ping around one. Oh, and it doesn't like this. If you remember me telling you this before, it does not like the number key for the Kali console for some reason. So ping 1.1.1.1. That gets us out. By default, that means we can get to our gateway. So 192.168.1.1. That's our gateway. .2 is our DNS load balancer. .3 is the actual DNS host 1. And then let's just try this. If we ping 10.1.13.12, that should get us to the host. Now, on that, that's interesting. So let's just leave this up for a second because this is one of the things that I kind of want to point out to everybody that we're going to do. We haven't done a lot in security yet as far as like securing the overall network. I am a big fan at doing that from jump, but I also am a big fan in the lab of like showing you all how we're doing this. And we've already had to deal with like some back and forth on the network where like I've had to go check things or move VLANs around. As soon as you add security to that, you end up with this whole other set of things. What ACL is applied? Why isn't this working? Is it a VLAN issue? Is it whatever? So right now, I'm going to implement a security thing. We've already got the cluster up. I understand how the cluster is working and the interfaces are working now. Ceph's working. CoroSync's working. The management interfaces are working. All that's working. We have a 2-node cluster up running Ceph. That's cool. Keep in mind, this host is running on Ceph. It is very performant right now. We don't know what that's going to look like over time as we bring more nodes in or anything, but for now, Ceph looks pretty good. So what we're going to do is I am going to go to the Unify network, and I am going to go to my network config. So settings, come on. Something's goofy here. So let's go to networks. All right, let me expand this out and see what I'm. Oh, we are on we're on the wrong thing. All right. So now what I want to do is I want to go into this VLAN 13, the storage and Ceph network. And what I want to do is I want to isolate that network. One, I don't want it to have internet access, which it doesn't right now. You guys saw me ping from that host earlier to the internet, but that was through its default gateway, so that would have defaulted to its interface. Don't worry about that. This 10 network should not have any internet right now. But what I want to do is I want to set up isolate network. And what this should do is put a default rule in place that says this network can't talk outside of its network and nobody else can talk in. And right now we have a host that's in the management VLAN 192.168.1 that is actively pinging this interface that is in VLAN 13, so 10.1.13.12. The other thing I'm going to do here is I'm going to spin up another one of these and ping both hosts and ping the gateway. So ping 10.1. And again, Kali doesn't like that in the Visual Console. So ping 10.1.13.13. And we should be able to see that host too. And let's kind of orient these here. And let's bring these up. Because we don't care about the whole ping string here. We just care about the live pings. So I don't care about any history on this. Let's just try to get a pile of them in there. There we go. And let's bring up one more. And we're going to ping 10.1.13.1, and that is the gateway. And if you're already a networking person, you know this, and I've mentioned this a few times, but you can ping inside of your L2 network. So in our case, you can ping inside of the /24 from another host in the /24 all you want. That's just L2. That's layer 2 networking doing its job. As soon as you try to go between, in our case, one /24 to the other, then you're routing. Or when you try to go to the outside of the local network to the internet, you're routing, which means you have to go to your gateway. In the case of this network, so the 10.1.13 network, its gateway is .1. I've seen this work a couple different ways, depending on how routing's set up, depending on the devices. I haven't tested this on Unify yet, which is why I'm doing it. What should happen is as soon as I hit isolate network and apply it, and that goes down through the SDN controller for Unify, what should happen is that we lose our ping from 12 and 13 because those are hosts on the network. I'm guessing I can still ping 1 because 1 is where the ACL is likely being applied. So we'll be able to hit 1, but we're not going to be able to go past it. And we should see that in real time. So if this one keeps pinging and these two die, then that's just standard behavior on what I've seen before. If they're doing something different in Unify, we could lose all 3. I don't know. And that just means because we're using the USG Pro, the Security Gateway Pro from Unify, that it's applying it in the security module on that as opposed to at the actual interface and saying, oh, nobody's allowed talking to that network at all, die. And we'll see it here, or should see it. So we're going to click Isolate Network, and I'm going to apply the change. That is going to take a couple seconds to parse its way out through the network. And what's going to be really disappointing is if nothing changes. Which tells me that we're actually not getting, it tells me one of two things, and we'll test those. It tells me we're either not getting true network isolation through that. We could probably do it other ways. Or it's telling me that we have this is an active connection, and it'll let the active connection continue. So we said, what did we say here? We said that this network, 13 network, we told it to isolate it. Clearly didn't isolate it. So let's try this. So now we're going to kill that ping, and we're going to start a new one. Nope. So it's not even an active connection issue. So I'm a little curious about this because, again, I feel like security is super important in these components. So let's jump back. And we had a switch isolation setting. So device isolation, block all communication between devices in the same network. We don't want to do that. And we have block all IP4 traffic between devices in different networks. This blocking is applied at the switch level using IPv4 access list. Let's try that. I don't want to try that because it says block all IP4 traffic between devices in different networks. I have a feeling that's going to break things. So ignore this. We're going to move back to the cluster. We're going to leave this going, and we are now going to, again, we're going to look at cpool 1, and we're going to see that cpool 1 has all of this stuff, has all the disks already mirrored between it. We're going to go to Kali. We're going to do a migrate on Kali. We're going to do it to PVEC2. Now that's interesting. So I don't know if it's because it's an online migration or not. I don't think it is because I think we did VLAN 10 as a live migration. But it didn't give me the chance to change the configuration. So we'll have to play with that. We might not be able to go from the C pool, so the Ceph pool, back to ZFS. And if we look right here right now, that we've already completed our migration. All it did was do a migration of the running memory. And if you guys look, this already came up. And if we were to scroll up here, I don't think we even lost a ping. Yeah, we didn't even lose a ping um, across networks in here. So one, that was super fast. It was a pure migration. It took 22 seconds, dumped the 4 gigs of memory across the 10 gig channel, and we were done. That tells me that the synchronization is really good. Yeah, that's it. We are set up with Ceph. We are set up with backups that we've already done. Now, while we've done this, the last thing I'm going to have you guys do. Oh, that's interesting. I killed my ISO share somehow. And I think I know how I did that. I think I had migrated this ISO share. No, I don't know how I did that. Yeah, I do. We don't need to go into it, but if we go into TrueNAS, I'm pretty sure we had that running on the 10 gig interface. And I think that is why it died. I think that's why we lost it there. I am also going to go back into here just for sake of doing this and unisolate the network, because that could have been the problem too. But for some reason that doesn't feel right to me. I think when I pulled that interface was the one that TrueNAS was running its storage volume off of on here. If we look at hardware and I look at network interface, yeah, I don't know what I did there because that's not right either. I did something in this stuff to break the ISO. I'm not super worried about it right now. That is just how we're doing our boots. Again, we have a lot of things kind of in motion here as far as what's going on the network. And once we get everybody into the cluster, I'll be able to go through and say this is the final state of the cluster. All right, so final thing I'm going to do, I'm going to go back into PBS now. And I'm going to go to backups. And we are going to start restoring everybody. So one of the things we're going to do here, I want to go into PBE 1. The only thing that we can't really migrate, TrueNAS is going to be big, and I don't really want to mess with it right now, but I am going to shut it down. I want all of these that we're going to start recovering powered off over here. I'm leaving the Kemp load balancer up because that's my primary DNS internally right now. We're going to do a migration on it in the next one. I haven't quite decided how I'm doing, but I'm mapping it out now. We're going to leave the Docker host up because that's where the service gallery lives. And it's also where Portainer lives, which that's neither here nor there. It's just what we're using to manage those. But more importantly, it's where Homar lives and the service catalog lives there. So I don't want to kill that and move that around in the midst of all this. Ansible control, I am shutting down. Ansible control is where I run Ansible and Terraform from for products and projects I'm working on. We're going to leave Unify up for now. It's backing up anyways right now, it appears. Looks like there's a backup job going on, which is going to die. And I'm going to have to go undo that. But it's up and running. The backup jobs are just going to start failing because I pulled that other interface to give it to the new cluster. What else do we have here? Pi-hole 1 stays up because that's our primary DNS, and we're good. Everything else can go. So if we go into PVEC1 in the backups, we want to move the Tailscale router. We're going to restore it. I am going to tell it it's going to cpool. We are going to look at its old VM, which is 117, which we can also see right there. So we're going to do it 117. 117. We're going to leave everything just like we did before. We're going to click restore. Going to kill that. We're going to go into, here's the other thing. It doesn't matter. We can restore all the, as long as we don't start them. So let's just start restoring everything. So we're going to restore the Kemp load balancer, 114. Not going to do anything with it. Storage is going to be cpool, restore. I'm just going to work my way down the list is what I'm going to do. Because again, it doesn't matter that these are restored as long as data is not changing on the other side that we care about. And in the case of all these are all static services. So the tail SR, we're going to turn it down to 1, turn it up in the other. Matter of fact, it's already turned down on the other. So as soon as it's done recovering, We might even be able to show that. So if we go in to our Tailscale management, so we're going to look, and like the tail SR is down right now. It also needs an upgrade, but let's just show that one. So if we go back to PBE1 and we look at tail 1, tail SR1 is down. And then we go back to the cluster, and then we look at restore on 117. So as soon as the restore is done there, we'll turn it up, and everything will be, as we expect it. So let's just go look here at summary. We're getting a warning on health for Ceph. So we're doing this. So we're undersized and degraded. So we don't have enough of the segments. Degraded 33%. And again, I think this is just about getting the right number of drives and the right capacity and everything up. Oh, this is cool. So we're now getting actual data, which is cool. So we're getting read and write I/O. That's awesome. We're actually being able to see the performance on it. We're seeing the usage that that there's 2.5 terabyte actually in the Ceph pool, and we're only using 1%. This is great. This is the exact type of stuff we wanted to see out of it, and I haven't seen this yet because I haven't been able to get a functional cluster up. But we'll be able to see where this maxes out, what our max I/O is, and stuff over time. But what we're also seeing with this is we're seeing this happen in real time, because if we then go look at cpool, we're looking at all of these VM disks that are being recovered, being written there, and they're being actively synced across here as well. So not only are we recovering them, but Ceph is actively syncing them back and forth between all the different volumes that we have, which is pretty cool. It's exactly what we wanted to see. And there we go. So we're looking at 1.3 terabytes, and then we go and we look at PVEC2, cpool and summary, 1.32 terabytes. Yeah, so this is, again, we're mirroring this volume across all those drives, with 4 of those drives living up here on PVEC1, 1 of those drives living on PVEC2. Eventually, we're going to have it with, I think, 8 drives on PVEC1, 2 drives on PVEC2 and PVEC3, and then PVEC4, which is the storage box. We're eventually going to bring that guy in, and he has a whole pile of capabilities disk-wise that the others don't. Like, he's sitting on a ton of disk, but we're going to carve him up in interesting ways so that his primary disk volumes are going to be tied back not to ZFS for store. Well, they're going to be tied back to a virtualized storage box. We'll get to that later. And that's just so we can maximize the use of our lab for what we're doing. So to get the most bang for our buck out of our hardware. All right, so where are we here with PVEC1? We're still restoring 117. This is taking a while. We're restoring 2 at once. So the Kemp load balancer is already restored. That was relatively small. We're still restoring 117. I could start more restore jobs, but I'm not going to, because that's just going to compress down what we can actually pull as far as disk IO and so on and so forth. I doubt we're really hurting for disk IO right now on these guys. Yeah, like this guy's doing fine on disk IO. Disk IO's up a little bit on PVEC2, but again, those are just SATA drives, and we're asking a lot of effectively 1 SATA drive to be part of that cluster right now. And then as far as the networking goes, you'll see that network traffic's relatively low, probably on both of these guys. Yeah, we're not really doing much network-wise. Memory-wise, we're super low. On this guy, memory-wise, we're super low. Like, overall, we're doing really good on recoveries. There it is. So tail SR is up. We're going to hit start on tail SR. I'm going to bring up the console on it. so we can watch it actually boot in live. And then once this is done, folks, like we're at we're at 100, we're at an hour and 40 minutes. Like I'm way over the hour, but I feel like this one was actually super helpful for everybody. We'll probably deep dive more into Ceph and Ceph performance and capabilities later, but this is getting Ceph up. It's stupid simple to get Ceph up and running on these boxes. It surprised me in my nested lab. Again, the nested lab was such poor performance I couldn't do anything with it, but getting it set up was cake. Um, and I can see replication stuff across there as well, but just not like we have here. So once this is up, Tailscale Damon's starting, and now it's up. So we should be able to go back into Tailscale, and boom, it's connected. So we're already back into the Tailscale network. This is a hosted platform. If you don't know about Tailscale, it's WireGuard VPN with lots of cool stuff on top of it that kind of gives you a very quick and dirty VPN that's very secure. And this Tail SR router is just my SR router that I'm using to get into the rest of the network instead of deploying hosts all over the place. So it allows me to get some of my management network. But that's it, folks. Like that's where we're at. We've accomplished an incredible amount. The cluster's up. What I'm going to do between now and next time we talk, which should be tomorrow, is I'm going to go ahead and recover all of my VMs. I'm going to continue to do my backups by coming into PBS, looking at the backups. The last one we did was KLB. We're going to restore Docker host. And I'm just going to keep going through this process. Now, the interesting thing is, I think there is probably a way to do this that is more refined that would allow me to like do a batch recovery. I haven't really looked at it to know whether I can or not. I definitely know that all of these features are available via CLI, which should mean that I can use Ansible to do a lot of this stuff too. And maybe we'll play around with some of that stuff later. This guy is going to be the big boy right here. We'll just go ahead and start him right now. We're going to go look at TrueNAS 1. We're going to do restore on him. We're going to tell we want it to be 103. TrueNAS is by far my biggest volume, 500 and some gig, and that's just because I set up a big volume on it for all those ISOs. We're going to put that into cpool. Nothing else is going to change, and we're going to click restore. So aside from that, I'm going to have the third node ready to roll to bring into the cluster. I want to have you all with me live when I do my DNS and final migration of all my services so we can see how, if we plan it, it can be done quickly even without a lot of like secondary load balancers. Again, I haven't played with the idea of turning up another Kemp today, but I just kind of want to see what happens when we turn one on and turn one off and see the kind of implications of that. And then after that, while we're doing that, once that's turned off and we're kind of playing with things and turning all the services back up and the primary node, I'm going to also start the rebuild on node 1, and that'll bring us up to 3 nodes in the cluster, which will be the largest we've had the cluster yet, and then it'll allow us to bring Ceph into it and everything else. In order to do that, I am probably also going to try to figure out how to get SATA drives into the box tonight, which means I'll probably turn that node down after we're off stream. So I actually have a boot volume, and then I can have a single disk for ZFS local because I'm not sure how I feel about Ceph yet. And it's going to give me the ability to fall back and forth. I'm also probably going to play with what it looks like to migrate an offline host from the Ceph pool back into ZFS. We saw that it was easy enough to take a ZFS hosted node and put it into Ceph, but I didn't see an easy path there back, and I'll play with all that, and then we can talk about that in the next stream. Looks like one of you is on, maybe even stuck with me. If so, I appreciate it. All that aside, this is cool stuff, and I'm excited about it, and I'm glad we're actually to the true functional migrations at this point and starting to bring live services up on the new cluster. That's going to open up a lot of other functions for us, like starting to play with some of the networking components, implementing firewalls at the VM and host level. And then hopefully I'm looking to get a hold of a Nexus switch that would allow us to do some of the SDN stuff there as well and take it down, like the VXLAN stuff take it down into the actual switching fabric as well, but we're not there yet. But yeah, and with that, you even saw how quick that backup took. That was our single biggest host, and it's already restored. That's crazy. Um, Restores much quicker than it backs up. All right, with that, folks, I appreciate your time again. I'm going to bounce, and we'll talk to you all tomorrow. Bye.